In this chapter, we will be looking at quadratic equations. In this lesson, we will look at factoring trinomials and mixed factoring problems. But we will start with factoring of trinomials.
Okay, hi everybody. So in this lesson here we're going to take a look at factoring trinomials, which in most 20 level courses that is going to be the vast majority of the factoring you're going to do is going to be factoring trinomials. So this is an important one. And then we're going to look at mixed factoring, which basically means we're going to look at a handful of questions that that are all mixed up in terms of their types of factoring so that you don't know exactly what to do until you look at the problem. Because that's really the sort of the situation you're going to get on the exam. You're going to be given a bunch of questions asked to factor, and they're not going to be grouped together like these are the trinomials, difference of squares, and so on. So there's several different methods for factoring trinomials, and a good friend and colleague of mine, Mr. Gartke here, has got a whole bunch of them outlined right there. In fact, I'll zoom in a little bit so you can have a look at that. So he's got a video there. But what I'm going to do here is I'm going to run through probably the two main ones here. And I've got 6 questions that I'm going to work through here. And I'm going to alternate between, and it's going to sound goofy, but guessing and checking, which is probably the most efficient method in high school. And then I'm going to look at decomposition. So I'm going to alternate between guessing and checking and decomposition as I go through these 6 questions here. The reason I'm choosing decomposition is because it's going to utilize factoring by grouping, and we looked at that in a previous video. So anyway, I'm going to dive right into the examples here because to explain these things is probably a little bit easier just to show you what it is that I'm doing. Okay, so I'm going to start by guessing and checking here. So, and when I say guessing and checking, what I'm doing here really is I'm looking at the trinomial that I've got here, and I know that I'm going to break it down into 2 binomials multiplied together. And if you think about FOIL, okay, first, outer, inner, last, the way we distribute the terms of this binomial to the terms of this binomial, remember that the coefficient here is going to be the result of the first terms multiplied together. The last number here, this 30, this is the L, this is going to be the result of the last numbers multiplied together. And this inside here, this is your OI. But it's the outer product plus the inner product, okay? So there's a little bit of addition that goes on here to get this middle term. Now anyway, the reason I say guess and checking is really efficient here is because for the most part in high school, it really will be, because we're going to give you questions that in general are going to work out relatively nicely. So for example, to get this x squared right here, in particular this 1x squared, well, there's only one way to break apart 1, and that's going to be 1x and 1x. So now when I multiply the first terms together, I should be getting this guy right here. Now, I'm not going to guess at the OI. I'm going to guess at the L, okay? And then what I'm going to do is I'm going to use the OI, okay, this outer plus the inner here, to check to see whether my guess is correct. So for example, I've got 30 here. Well, factors of 30 are going to be 5 and 6. So I'm going to put 5 here and 6 here. Now, because this is positive, this product is positive, I know that these two are the same sign. And because this is positive, I know that these are both going to be positive here. So that's my guess. Now I'm going to check it really quickly by checking my outer and inner products here. X times 6 is going to be 6x. 5 times x is 5x. But when I add those two together, I'm not going to get 13. I'm going to get 11. So this is actually incorrect. So then I'm going to try again. Okay, there is only one way to get that 1x squared there. But now I got to look at different factors of 30 here. And the more comfortable you get with this, the quicker you're going to be. Another obvious guess here that some people might jump to immediately, and I'm just going to do this really quickly here, will be 15 and 2. Now, I can combine 15 and 2 to get 13 as long as the 2 is negative. But because of the positive here, I know that both of these have to have the same sign, and because this is positive, I know they're both positive. So this, again, won't work because 15 plus 2 is going to be 17, so it's no good here. Now, you might start to think, well, what are my other options here? However, there is one other option. It's 3 and 10. And there we go. And that will produce that 13 for my OI when I multiply those out. I'll get my 10x and my 3x. So that works. Okay, now I'm going to do this one using decomposition. So when I do decomposition, what I'm going to do is I'm going to try to produce the two numbers that give me the OI. Now, so what I'm looking for here are two numbers, and without getting into really a lot of the details as to why this works, just kind of at this point here, I'm just asking for a little bit of faith. I'm going to take the coefficient of the x squared and I'm going to multiply it by the constant. So 1 times 27, or actually, I should actually say x squared. I should just take the first term here, really, to be consistent here. X squared times 27 is 27x squared. So I've got a product here of 27x squared when I multiply the first term by the last term. Okay, my OI, remember that OI, that is the sum of the outer and the inner. So I'm using these two terms to create my product, but the middle term here is already the result of two terms there. Okay, so now what I'm going to be looking for here are two numbers whose product is 27x squared, whose sum is going to be negative 12. And right now, trying to find these numbers, that is the hard part of factoring. But it is hard, okay? The more comfortable you are with your multiplication tables and whatnot, the easier this gets. But this is the tough part here. And the two numbers I'm looking for here are going to be negative 3x and negative 9x. And once I've identified those, I know I can put those together. Those are my inner and outer products. I know I can put those together to get the negative 12. So what I'm going to do is I'm going to replace the negative 12 with those two. So this is going to equal x squared minus 3x minus 9x plus 27. So what have I done to this expression here? Well, honestly, nothing. Because negative 3 and negative 9, that combines together to get negative 12. So I've done nothing. But what I'm going to do now is I'm going to do grouping. Remembering that when I do grouping, I'm going to pull that negative in. I'm going to put a positive sign in between. And then in each set of brackets here, I'm going to pull out what's common. So in this first one, there's a common x. And in this second set of parentheses here, the second binomial, there's a common 9. Now I'm going to pull out negative 9 because I want the terms here to be positive and then negative if I can, just like it is here. And when I pull out that negative 9, I do get that. I get the x minus 3. And now what I've got is I've got this binomial factor, x minus 3, in both of these terms. So I know it's been distributed through, so I can factor that out. And I'm left with the x from the first term and the minus 9 from the second term. And so there we go. So this expression up here factors down to x minus 3, x minus 9. Okay. This one, I'm going to go back to guess and check. So I'm going to drop my two binomials here. And again, my first term is 1x squared, so it's really easy to break up x squared into x and x. And now I'm looking for two numbers whose product is negative 48 and whose sum is negative 22. Now, for a lot of people, when you see 48, immediately you're going to think 8 and 6. Okay, let's start with 8 and 6. Because this is negative right here, I know that one of these is negative and one of them is positive. And because this middle term here is negative, the OI, because remember this is the sum of those two. Remember this is first outer plus inner and last. Then when I add two numbers together and I'm getting a negative result, okay, it's got to be the bigger number that's negative. So that means in this case the 8 must be negative, the 6 is positive here. But when I multiply this out to try to check and see if I got that right, I'm going to get 6x and negative 8x. Well, those combine together to get negative 2. Well, that is not it. Okay, so I got to look for different factors of 48. Okay. So looking at 48, another one that you might think here would be 12 and 4. Okay, let's try 12 and 4 here. And again, my logic before still holds. I know that the larger number here must be the negative one, so that when I add them together, the result is negative. But when I multiply those together, I'm going to get 4 and negative 12. 12 here, and 4 minus 12 is going to be negative 8. So again, that's not that negative 22. So that's not it. I'm looking for another pair. Now, by the way, I'm making this look like it's taking a long time here, because what I'm doing is I'm going through the factors of 48 that tend to occur more often. But again, the more comfortable you get with this, the faster guess and check becomes. And it turns out, oh, the numbers that I'm looking for here are going to be 24 and 2. Make the 24 negative, make the 2 positive. And yeah, when you multiply those out, you'll get positive 2, negative 24, and that does add to get negative 22. That's the OI that I'm looking for. So those are the factors that I'm looking for. All right, remember, I'm going to do this one using decomposition this time. So decomposition, I'm looking for a product and a sum. So my product is going to be taking the first term and multiply by the last term. That's going to give me 30x squared. And my sum, this middle term, well, that is already the result of two terms being combined together. That's the OI. So now what I'm looking for are two numbers whose product is going to be 30 and whose sum is going to be 13. Well, okay. I could think immediately about 15 and 2, but in order for those two to combine to get 13, one of them has to be negative. And if one of them was negative, the product would be negative. So that can't be it. So this has got to be, just like we were doing before, this has got to be the 10 and the 3. So 10x and 3x, those are my two numbers that are going to combine to get 13x. And when I've been saying numbers, I should be saying terms. These are the two terms. That's sum to get 13x and whose product is going to be 30x squared. So now what I'm going to do is I'm going to replace that middle term here with 10x plus 3x plus 6. So again, what have I done to the original expression? Nothing. Because 10x and 3x is 13x. I've just basically just split that up a little bit. And now I'm going to use grouping. And I feel comfortable with grouping because we did that earlier. I was expected to know how to do grouping. What's a common factor to those first two terms? Well, 5x, so I will factor that out. That'll leave me with x plus 2. What's a common factor to 3x and 6? 3. And that will leave me with an x plus 2 when I factor that out. And so now I've got this common binomial factor, x plus 2, that's been distributed. So x plus 2 is common, so I can pull that out. And it's been distributed to the 5x and the positive 3. And there we go. That's the factored form of that expression. I hope that makes sense. We're going to do one more example of each here. So here, again, now I'm going to apply guess and check to this, but before I do, this is the first time we've run into a question like this. Actually, there's common factors to all three of those. So actually what I want to do is I want to pull out the common factors first. So I've got a x, first of all, that's clearly common to all three of those terms. But when I compare 6 and 33 and 45, there's also a common 3 there. So I will factor out a 3x first, and that's going to leave me with 2x squared plus 11x plus 15. Okay, and so now it's this trinomial that I really want to tear apart. I've still got that factor of 3x there, but I'm going to break this apart into two binomials. And now this one's a little different because I've got a coefficient here that's not 1. But it's still not that bad because 2x squared can only be broken up into 2 and 1. So 2x and 1x here. Now 15 commonly gets broken up into 3 and 5. Okay, or 5 and 3. I mean, it could be 15 and 1, but let's just start with 5 and 3. So 5 and 3. This is positive, so I know that these two are going to have the same sign. This is positive, so I know that these are both going to be positive. And now when I expand this out, 2x times 3 is going to be 6x, and 5 times 1 is 5. And I know that 6 and 5 is going to be 11. So actually that was a really good guess. And so that's the answer in factored form. Actually, I was literally expecting to do one or two more to flip those around, but that's it, perfect. And this last one here, I'm going to factor this one using decomposition. But I'm going to do something first here. I don't like the way this one looks. I want it to be in standard form here. So what I want is I want it to be in terms of decreasing degree on the term. So I want my 6x squared first, plus 7x minus 5 at the end here. That is, sorry, that is a far more user-friendly expression to factor here. And now once again, I'm going to use decomposition here. So I'm looking for a product of negative 30x squared. And I'm looking for a sum. My OI is supposed to add together to get me positive 7x. Okay. So now let's just kind of think through factors of 30. Well, 5 and 6. Now, regardless of the fact that this is a negative product, so one of them has to be negative, one of them has to be positive. There's no way I'm going to get 5 and 6 together to get 7. That's just not going to work. And likewise, neither will 15 and 2. So once again, I'm back to 10 and 3. Now notice this. The product is negative, but the sum is positive. So the fact that the product is negative means that one of the two of them is negative. And the fact that the sum is positive means the larger one is the positive one. So this has got to be 10x and negative 3x. And so now I can split this up, or at least what I can do now is I can replace the 7x with the 10x and the negative 3x. So 6x squared plus 10x minus 3x minus 5. Now I often get asked, does it matter what order you put those numbers in, or those terms in, the 10x and the negative 3x? And the answer is no. If you put this in a different order, you're going to get the order of your binomials in a slightly different order, but that's okay because order doesn't matter for multiplication, so it's fine. And so now we're going to do grouping. And remember, I'm going to pull that negative in with the 3x. And I'm going to make sure there's a big old addition between the two of those expressions there. What's common is 6x squared and 10x? Well, that's a common 2x. And when I factor that out, I'll be left with 3x plus 5. And then over here, what's common to both of those? Well, not much. But there is a negative that's common, and I will pull that out. And actually, that gets me 3x plus 5. And that's exactly what I wanted. There's my common binomial factor. And if I factor that out, or write it out front, what has this been distributed to? Well, it's been distributed to a 2x and a negative 1. And so there's the factored form that I'm looking for. So now we're going to take a look at a set of questions where we don't know prior to going in what kind of factoring we're going to need.
And now we'll look at mixed factoring problems.
Okay, so before we get into the exercises here, some things to think about when you're talking about mixed factoring here. First of all, always remove greatest common factors. That should be the very, very first thing that you do. I've watched all sorts of students get really frustrated with factoring because the numbers they were working with ended up being so big. Like they would do decomposition, but their product was really big, and they got frustrated. And the key to that was just removing the greatest common factor. It made the trinomial that they wanted to factor so much easier to work with. So please look out for that. If you've got two terms, check to see if it's a difference of squares. If it's got three terms, then it's going to be like the trinomial factoring that we've just been doing. So you might want to guess and check, or decomposition, and there are other methods that you can do for sure. And then if you see four terms, then you certainly want to check and see if you can factor that by grouping. Now, sometimes if grouping doesn't work for you, sometimes what you can do is just change the order of the terms, and that will fix that. Sometimes even though the grouping didn't seem to work, just by fiddling with the order of the terms, you can actually make it work. So don't give up too soon. Anyway, let's start looking at some examples here. Okay, so we're going to start with 5x squared minus 15x. Well, first of all, I notice that there's a common 5x to both terms here. So I know that 5x was distributed, but what was it distributed to? Well, it was distributed to an x and then a negative 3 when I divide 5x out of both those terms. Now, what I'm left with here is a binomial. It's got subtraction in it, but it's certainly not a difference of squares. There's nothing else common, so that's it. That's all I can do. That is the end of that question. Okay, don't try to pull that apart into trinomial factoring. Some people really do. They get so comfortable with trinomial factoring that even when the question isn't an example of that, they still try to make that work. So that's it. That's as far as you can go. Okay, same thing here. The first thing I want to look for here is a common factor, and I see there's a common factor of 3. And that will leave me with an x squared and a minus 25. And now I can see right now that I've got two terms, so this looks to me like it's probably a difference of squares. And I've got a square as the first term, square as the second term, so that's what that is. And so now I don't even have to think too much about this. I know this will be square root of x squared minus the square root of 25, and then the square root of x squared plus the square root of 25. There's nothing else I could do. There's no more common factors, and everything is as reduced down as I can get it. So I'm good. That's it. Okay, 3x squared plus 6x minus 45. Now I can see that it's got three terms, so I'm looking. It's looking like this might be trinomial factoring. But the first thing I've got here is this common 3 to all three terms, so I'm going to factor that out first. And when you take 3 out of all those terms, you're going to get x squared plus 2x minus 15. And this trinomial, when I look at 15, okay, well, think of it like this. When I multiply the 1 by the negative 15, I'm going to get negative 15x squared there. So I'm looking for two numbers whose product is negative 15 and positive 2. And actually, that's not all that hard to even guess. Because the most obvious factors of 15 are going to be 5 and 3. And those do differ by 2. So as long as the 5 is positive and the 3 is negative, and if you're wondering how did I know that the 5 was positive, bear in mind that the 15 here is negative, meaning that one of these terms is positive, one of them is negative. But because the middle term is positive, that means the larger of the two numbers here, that's got to be the positive one. That's how I knew. Question 4, once again I see the three terms, but I have a problem with this one. I don't like the order that it's in. I want it in a more standard form here, so I'm going to just change the order. So 6x squared minus 4x minus 16. And then I'm going to take out the common factor of 2, because I notice that every one of those numbers there is even there, so I'll take that out. That'll leave me with 3x squared minus 2x minus 8. Okay, now I could guess and check, but you know what? I'm going to do decomposition this time. So I'm looking for two numbers whose product is going to be negative 24x squared. I should say two terms whose product is negative 24x squared and whose sum is going to be negative 2x. Whoops, and I got to think here. What are two numbers whose product is negative 24, whose sum is negative 2? And actually, it doesn't take too much guessing here to realize it's going to be negative 6x and positive 4x. So now I can replace that negative 2x in there and make this 2 times 3x squared minus 6x plus 4x minus 8. And now I'm going to come down here and I'm going to split that up. I'm going to do some grouping. Now I know that looks a little bit awkward because I've got the two sets of parentheses there. But I hope you realize that the reason for that is I still need to have this 2 here. So I need parentheses around the whole thing with the 2 out front, just to indicate that that 2 is still a factor. And now I'm going to take out, wow, I can't believe I just wrote a 3 there. And I know why I did, but that's supposed to be the 2 bracket. Now, what's common to those first two terms there? 3x, and that'll leave me with x minus 2. And over here, there's a common factor of 4. That'll leave me with, again, x minus 2. So I know I'm on the right track as soon as that common factor pops out there. And now I've got this factor of 2 that I had right from the beginning. And in here, I'm going to have this x minus 2 that was common to those two terms. And it was distributed to a 3x and a positive 4. And there we go. Now this last one here, a little bit more complicated, but don't let the fact that we've got this x plus 4 in here throw you off here. Okay, because remember the first thing I want to do is look for a common factor. And notice that every one of these terms in it has a factor of x plus 4, x plus 4, x plus 4. So just like with grouping, when I pulled out the common binomial factor, I'm just going to pull out this common x plus 4. Now that was distributed to a 6x squared a positive 7x, and a negative 3. And now I've got this term here to factor. Now, this time around, I just did decomposition, so this time around I'm going to try guessing and checking. There's nothing else common here that I could pull out here, so I'm going to guess that 6 is going to be 2x and 3x. Now, my factors of 3 are going to be, well, and that's easy, it's going to be 1 and 3. But I want you to pay attention to this, because this one here is a little different here. Because a lot of times people will look at me and say, guessing and checking, that seems like such an inefficient way of doing this, just guess and check. And yeah, I understand where people are going with that, but you can eliminate some guesses here. So just to show you here, and I'm going to erase this as soon as I do it. If I put a 1 here and a 3 here, that is actually not a very good guess. And the reason for that is there's no common factor here. Okay, in this 6x squared plus 7x minus 3, there's no common factor at all. But I'm guessing a binomial that has a common factor of 3. Which means if I stuck with this, in my next step, I'd have to factor out the common factor of 3. But there is no common factor. So this doesn't actually make any sense as a guess. I'm introducing something into this expression here that doesn't exist. So instead, if I'm going to guess that, let's put the 3 here and the 1 here. Now, can I expand that out and get the 7 there? Now let's watch this. This is negative right here, so I know that the signs differ. And I've got a positive here, which means the larger value here in my oi has got to be the positive one. So in my oi, I'm going to have 2 and 9. Well, I want the 9 to be positive. I want the 2 to be negative here. Now, does that work to get me 7 there? Yes, it does. And so there we go. There's the factoring for this expression up here. And even though this one was fairly intimidating looking, it actually broke down fairly nicely for me. So I hope that makes sense. I hope that gives you some idea of how to go about factoring, and it gives you some confidence as you go through and do this.